This is Mr. Beck Does Your Homework. This is AP Physics, Homework 9.3, question number 3 and 4. Question 3 says, a Van de Graaff generator is charged so that the electric field at its surface is 83,000 newtons per coulomb. That is my electric field strength, E, is going to be 83,000 newtons per coulomb. What is the magnitude of the electric force on a proton released at the surface of the generator? The mass of a proton is 1.6726 times 10 to the minus 27. So that's my mass of a proton is 1.6726 times 10 to the minus 27. And the fundamental charge, or the charge on the proton, is Q equals 1.602 times 10 to the minus 19th coulombs, and that's kilograms. So it says, what is the magnitude of the electric force on a proton? Well, I know that my force on a charge, my electric force, is going to be, you could try to do K, Q1, Q2 over R squared, but you don't know Q1, but they give you the E field right there. So I know that my force is going to be the amount of charge times the electric field. So my force is going to be my 1.602 times 10 to the minus 19th coulombs times my electric field strength, which is 83,000, and that is going to give me the force on the proton. And this is in coulombs, and this is in newtons per coulomb. So coulombs cancels out, and I'm left with newtons of charge, and that's what I want, answer in units of newtons. Now it says find the proton's acceleration at this instant. Well, now you have to think back in your brain and remember that the force on something equals the mass times the acceleration, or the acceleration is the force divided by the mass. And since you have this force up here and this mass of the proton right here, you can use your force divided by your mass to get your acceleration, and that in standard units will be meters per second squared. So this is going to be your answer in meters per second squared.